Okay. So panel board designing, in last session we have already completed how to design a DB and how to create the schematic for a DB. So next we can discuss how to create the panel scheme. Okay. So this one we already discussed in the previous class how the distribution occurs from the HT side to the LT side, that is from the transmission side till our DB. So okay, so this part, our DB part, we already completed. Next we can start with the SB panel, 5 pump panel, common panel, or MSB panel, SSB panel. So these panels we can design. How to do the calculations for that. Okay. So first thing, we'll start with the SSB panel first. Okay. So how to design an SSB panel? So from the SSB panel, we are actually providing the supply to the DBs. Okay. And one more thing before starting with the calculation part, I'll like to explain a term called multiplication factor. So multiplication factor means actually a unit value which you are providing instead of using the P is equal to VI equation. So every time when you do the calculation, it's not possible to repeat the equation every time, right? So instead of that, we will find out what will be the power for 1 kVA or what will be the current rating for 1 kVA. So the idea is this much. If you know the cost of one pen, we can find out the cost of 20, 30, 40, 50, whatever the number it is, right? So the same idea we are applying here. So we'll find out what will be the ampere rating for 1 kVA. So we can find out the ampere rating for 10, 20, 30 kVA, okay, depending upon the numbers. Okay. So first one, we'll find out when the supply voltage is 230 volt, that means for single phase connection, we'll find out the ampere rating. Okay. So the voltage is 230 volt and the power is 1 kVA. Okay. So we know the equation that is P is equal to voltage into current. That means current is equal to P by V, right? So that equation will be power by voltage and power is 1 kVA and the voltage is 230. Okay. So here it's in kVA rating, kilovolt ampere. So we have to convert the kVA to volt ampere. So that we will multiply with 1000 so that we'll get the numerator side in volt ampere. So that this volt and volt will cancel. You'll get final answer in the ampere. Okay, so that 1 into 1000 divided by 230, you'll get 4.35 ampere. Again, you don't have to by heart this one. Just understand how we are getting this value. This is the only thing you need to notice, that is 4.35 is the multiplication factor for single phase connection. That's it. So this is how you get the 4.35 value. Okay, got it. So that was the first one for single phase connection. Next, the same thing we had to find out for three phase, because three phase the equation is a bit different. Okay, so in single phase connection equation is I is equal to P by V, right? For three phase connection it will be P is equal to root 3 VA, so that I is equal to P by root 3 V. That's the change. Okay, so same way, supply voltage for three phase will be 415 volt and the power will be 1 kVA, so that P is equal to, I is equal to 1 kVA divided by root 3 into 450. Okay. Same way, you have to multiply with 1000 to convert the kVA to volt ampere. So that 1 into 1000 divided by root 3 into 450, you'll get 1.4 ampere. So 1.4 is the multiplication factor of three phase. Okay. Now finally, for the 11 kV, again 11 kV voltage, then 1 kVA power, same equation, same thing. But only thing voltage is changing here. Okay, so 1 kVA divided by root 3 into 11 kVA. Again, here we don't have to multiply with 1000 because the numerator is in kVA, denominator is in kV. So this kV and kV will cancel. I will get what? 0.0525 ampere. Okay, so these are the three factors you have to note it. Single phase it will be 4.35 and three phase it will be 1.4 and 11 kV separate will be 0.0525. That's it. Okay. Now coming to the panel board. First, we can start with the. Okay, so this one clear and out up to here this spot. So SSB panel design. So here you'll be having two part. You'll be having an upstream diagram. then you will have a downstream. So upstream is representing the schematic of that panel, and downstream will be the table contents. That means the cable size, MCB rating, earthing size, voltage. So those data will be given in the downstream. Okay. So first of all, I'll explain this one. So this is upstream, and here is the main incomer part. Okay. So in the main incomer, we have an isolator placed here. Then we have one, two, three, four, five. So five distribution boards. So 5 dBs are taken from this single SSB band. And so maximum numbers you can take is 8. So from here, or in this case, it's 5 numbers are taken from one SSB. Okay. And you can see that the corresponding load for each dB. So each dB bar GF bar S1. This means distribution board, the floor name, this is the ground floor. And S1 means it may be the number of an apartment or number of the shops given assigned to that. Okay. So for S1, S2, S3, S4, and S5. So for each dB load is given here, the 16.6 kilowatt. So you know how to calculate the connected load for the dB. So the dBs are given here. Then 4.35 kilowatt for the second one, third one 2.6, 2.16, 12.36, and 1.2. So these are the load for each dB kilowatt. So from here, one thing is clear. This one is single phase and three phase are combined. So these, okay, so this one is three phase. Again, this one is three phase. Remaining three are single phase. Okay. So here, what we have to find is, we have to find out based on this connected load, we have to calculate the rating of the circuit breaker here. Here we have one circuit breaker. Here we have one circuit breaker. Then we have the fuse. We have to find out the fuse rating. Then we have to find out what will be the cable size for this circuit, or to this connection, what will be the cable size. And finally, the isolator rating. So we have to find out this much things based on the connected load cable. Okay, clear? And CO means changeover. I'll explain in the coming session what is changeover and what is how it is used. So you can see that there will be a backup system is given here. I'll explain the next class regarding the changeover system. Okay. So this is the schematic, or we call it upstream for the SSB. Okay. So we'll start with the calculation first. In the downstream, again, first one given feeder name. Feeder name is the panel name or the DB name. You can give it here. Okay, so here SSB 1 bar 1 means first connection, second, third, fourth, and fifth. So we have 5 connections each. So that one given each table. Then also below that you can see connected load in kilowatt, maximum demand in kVA, current rating, factor of safety, MCB rating, factor of safety for cable. I'll explain this one and why it is taken, and cable size, earthing, voltage. So these are the contents of this table. First one feeder name, as we explained, you can give the name of that panel or name of the apartment. Depending upon the project nature, you can give the names for this one. Okay. Below that, you have to write down the connected load in kilowatt. Okay, so this is the connected load in kilowatt. It is given, so you have to note that one. Okay. Then below that, you have to find out the maximum demand. That means you have to convert the kilowatt value to kVA. So we already know the equation. Maximum demand equation, that is what? Total connected load divided by diversity factor into power factor. This was our equation, right? So using that one, you have to convert the kilowatt to kV. Then you have to find out the current rating, water safety, then the MCB rating. Okay, so we'll start with the first one. Again, everything is actually repetition. Only some minor changes will be there depending upon the single phase or three phase. That's it. Okay. So first one is 16.6 kilowatt. Here, 16.6 kilowatt convert to kVA. So 16.6 divided by diversity factor will be 1.5, because this one, it's not specified what is the project or anything. It's not specified here, but I'm assuming it will be a residential or a commercial project, so that this will be a variable load condition. Diversity will be variable, so that you will take 1.5 as the diversity factor. Then the power factor, it will be consider 0.8 always. So you can take that what 0.8 as the power factor so that you will get 13.83. 13.83 is the kVA value. Then you have to find out the current rating. Okay. So here 13.83, you have to find out the ampere rating. So usually what you'll do is you'll apply in the equation that is I is equal to P by V. But instead of that, we already learned a term that's called multiplication factor. So instead of using the equation, you can use the multiplication factor here. That is for three phase. This is three phase, right? This is three phase connection. For three phase, the multiplication factor is 1.4. So you just what multiply the kVA value with the multiplication factor. So 1.4 into 13.83 will get 19.37. Okay. 19.37, you have to add a 20% factor safety because in order to select an MCB or a cable size, you have to add a factor safety minimum of 5%. Again, depending upon the client requirement, anything, or the future expansion, you can add more factor safety. So here, I will consider a 20% factor safety so that 19.37 into 1.2, you'll get 23.24. After 23, the next available rating MCB will be 32. 32 is there. I think 25 is there. Okay. Yeah, 25 is there. After 25, 32 is there. Okay. So you can select any 25 or 32, both are fine. So that 32 will be the selected MCB rating. Okay. And based on the MCB rating, you have to choose the cable size. Okay. So 32 ampere here, cable size. Okay. So again, come to the data book, page number 8. You can see here after 25, 32 is there. So this is 32. So here runs is 1 and the size is 10, right? So that 1 runs, core I'll explain, and cross-section area is 10 mm square. Okay, so that just come to the table here. You can see that this one is a three-phase connection. So we already discussed that in three-phase connection or in cable sizing, three-phase connection, if the ampere rating is more than 50 ampere, you have to go for 3.5 core cable. Below 50 ampere, you have to go for 4 core cable. Okay, so that here you can see 32 ampere and it's a three-phase connection, so that it will be a 4 core cable. So one runs 4 core and 10 mm square will be the cable size. So this is the order you have to write down. Okay. Now for 32 ampere, you have to choose the earthing as well. So earthing again is in same page number you can get here. For 32 ampere, earthing SWG means standard wire gauge. So it's a unit actually you want to measure the thickness of that cable. Okay. So lower the standard SWG, higher the thickness. That's it. It's opposite. Okay. So you can see that as the current rate increases, SWG is decreasing. That means it's not decreasing the cable size. Lower the number, higher the cable size will be. Okay. So that is 10. So just note down that one also. 10. Cu means copper. If it's aluminum, it will be Al. Okay. So here we are using copper wire to what? Provide the earthing for this panel. Okay. Then voltage, as usual, you already know in three-phase connection, the voltage will be 415. So you can just note down that one as well. So better to note it first. Okay, so it will be better. So this is how you calculate the panel board design for a three-phase connection. Clear this one. Next, I'll explain one for the single phase also because everything is similar. Okay, the calculation. So these already we covered in the previous classes how to select the MCB rating cables and everything we already completed. So just again, just repeating. Now next is S2. S2 is apartment 2 and it's a single phase connection. Okay, so this one is a single phase. This is the only thing you have to note down. Okay, whether it be single phase or three phase, based on that, you have to choose the equation than the uh, cable size and everything. Okay, so 4.5, 4.35. Again, first you have to find out the KVA rating, that is substitute in our equation, that is 4.35 divided by 1.58, you'll get 3.63. 3.63 again here. This is single phase connection and the maximum demand is 3.63. And the multiplication factor for single phase connection is 4.35. So just to what? Multiply with multiply with 4.35, so you'll get 15.77. So that will be the current rating. 15.77 into 1.2, that is 20% factor safety, you'll get 18.9. That means around 19, you'll get what? The factor safety value. Based on the factor safety, you have to go for the ampere rating. Okay, so MCB rating will be 30. So actually, we can ask, why don't you choose the 25 or 20? Because in future, if you want to expand the system or if any additional things are adding, it is what not possible to change MCB every time. So when you place an MCB, you'll always go for what? For a higher rating. Okay, so most probably for a single phase connection or a three phase connection, the main incomer will be what? 32 ampere. Okay, so 32 ampere. Now, based on 32 ampere, you have to choose the cable size. Okay. Again, first thing, we have 32. 32, same one. Runs will be 1 and size will be 10 mm square. Okay. But here the connection is single phase, right? For single phase connection, the cable core will be 2-core cable. Okay. So, 1 runs, 2-core, and 10 mm square will be the cable size. And the earthing, again, same as well. In the same page number, you can find out the earthing as well. That is 10 again. So, 10 will be the thing, and the voltage will be 230 volt. Okay, because it is single phase. So in the same way, you can also find out the remaining panels as well. So this one again, it is single phase again. This one is three phase, and this one again will be single phase. That's it. Okay, so similarly, you can find out for the remaining panels as well. Okay, got it. Okay, so now as of now, we have got the circuit breaker rating of these two. Okay, and the fuse rating will be same as circuit breaker. So if you got circuit breaker 32 ampere means this one also will be 32 ampere, and the changeover rating also will be 32 itself. Okay, same way here also it will be 32 ampere, and here also 32 ampere, and the next one it is 16 ampere. So that third one is, this one is 16 ampere, this one is again 16 ampere, fuse also 16 ampere. So like that, how you take the rating for the circuit breaker and the cable size. Okay, so this is the cable connecting to the circuit. So cable size as we written. And now, okay, so now we can find out the isolator rating. So isolator is actually placed in the main incomer side. So to find out the connector load for this isolator or connector load for this entire panel, just what? Add all the connector load for the individual dBs. That is 16.6 plus 4.35 plus 2.16 plus 29 kilowatt. Okay. So once you add all these, you'll get the total connector load for this entire panel. Okay. So that will be the rating we have to provide for the isolator. Okay, same for DG also. Okay, so the DG is also providing to the same panel. So whatever is the rotor rating here, same will be applicable for DG also. Okay. So once you add all these rating, you'll get 36.73 kilowatt. Okay. Now, again, it's given in kilowatt. You have to convert to kVA to find out the maximum. There's 6.73 divided by 1.5 into point 0.8, we'll get 30.6 kVA. Current rating is equal to multiplication factor. Again, it's a three phase. Okay, so here we have single phase and three phase are mixed. But at the end or in the main income side, it will be three phase itself, right? So you have to multiply it with 1.4 into 30.6, 42.8. Then factor safety again adding a 20%, so you'll get 1.2 into 42.85 will be 51.42. So once you got this value after factor safety, you can come to the table again, page number 7. Here you can see a column for isolators. Okay. So for isolators, it will be 51 points. After 51, next available is 63. So 63 will be the rating of this isolator. Okay. So that's how you calculate the SSP4. Same rating will be given as well as here also. If it is 63, this isolator also will be 63 itself. Okay, 63 ampere. So no changes. Okay, clear. Okay, so moving to the next one. Next is motor panel. Okay. Uh, okay, motor panel. I'll do one thing. I'll just explain tomorrow once we start with the starters. Then I'll move to the motor panel. Okay, so for now, I'll just skip this part. I will start with the SP panel. Okay, so that means after SSB is over and to SSB, the connection is coming from SB. Right, so we can start with the SB panel here. Okay, so this one is our SB panel. So in SB panel, the maximum number of outgoings or maximum number of SSBs you can take from SB is 8. Okay, so 8 SSB you can take from one SB panel, or the rating will be 1500 ampere. Okay, so let's see how to design that one as well. Okay, so this is the schematic for an SB panel, upstream diagram. Okay, again, as usual, we'll be having a main isolator. So this isolator or this incomer will be coming from the MSB. Okay, so the connection to the SBs are coming from MSB, and the connection to the SSBs are coming from SB. That's it. Okay. Now here, accelerator is given as the main incomer. Then a bus bar is taken from the bus bar. 1, 2, 3, 4 SSBs are taken from this particular SB. And for this SSBs, the main incomer is actually a MCCB shown here. Okay. So as the current rating increases, you will go for what? MCCB. Okay. So up to 63 ampere only, we'll suggest a MCB. If it goes above that, you have to go for MCCB itself. Okay. So for SSBs. Okay. So let's go to the downstream. First one, 45.36. That's the connector loop. The same way, 45.36 divided by 1.5 into 0.8, it will be 37.8. 37.8, you have to convert to, sorry, you have to find out the current rating first. So it's a three-phase connection. So multiply with what? 1.4 to get the current rating. So it will be 52.92. Then we have to find out the factor safety. So factor safety again 20%. So the current rating value into 1 point will get 63.5. Okay. So next is MCCB. Okay. So MCCBs are written in a format that's set the value by, sorry, switch value by set value. That's right. Okay. So here, switch value means the maximum rating of a MCCB. That's the switch value. Okay. Set value means it's also called the trip value. That one we can manually set depending upon our connected load. Okay. So here you can see that we have current rating value. Current rating means this is the maximum ambient rating which will be coming to our system. Okay. That one I got 52.9. So this value I will consider as a set value. Okay. This one I will round off and I will give as a set value. That means 52.92. I'll just round off to 55 ampere. Factor safety again 20% is considered. So 52.92 into 1.2, that will be 63.5. So 63.5, what is the value after 63? That's it. Okay. So after 63, come to the MCCB. After 63, 80 ampere is available and 100 ampere is available. So you can go for 80 or you can go for 100 as well. Here, 100 by 55 is selected. So this will be the MCCB rating. Okay. So this set value we can change depending upon our load changes. So if you add more components, if our connected load increases, you can what? Change from 55 to a 60, 70, maximum up to 100. Okay. And the cable size. Okay, so here in MCCB, in case of MCCB, the cable size is selected based on the switch value. That is, what is the maximum rating? The maximum ratings cable size will consider because 55, this is the value will change, right? I can change this one as per my requirement. So every time we have to change, or whenever you're changing the set value, you don't have to change the cable, right? So that maximum rating will be considered for the cable size. So 100. So for 100, here it is. Okay. So runs is 1, cross section will be 70. Okay. So 1 runs core. So you can see that again it's a three-phase connection, but the rating is above 50. So above 50 means you will go for the 3.5 core. So 1 runs 3.5 core and 70 square will be the cable size. Okay. And earthing here in the previous case, when it comes to a dB, you can go for the cable earthing. Okay. Whenever current rating increases, you have to go for the next step, that is strip earthing. Okay. So earthing again, I'll come in a different class for earthing is the. So here we are using a strip to earth the panel. So that strip size is given here, 25 by 3. It's in mm. 25 will be the width and 3 will be the thickness of the strip. Okay. Cu again means copper. So copper strip of 25 by 3 is used to air this panel. So that's what our downstream will be. Again, all the connections are three phase itself. So no change in any calculation or equation. The same way you can also what? Yeah, calculate for the remaining panels as well. Okay, clear. Okay, so the strip earthing rating you can what? You can take from here in page number 13, corresponding to the ampere rating. So we have 100 amperes. So 100 ampere means you can go for 25 by 3. Okay, so just take the earthing from here. Then finally, isolator part. That's our main e-commerce. Okay, so same as before. Just what? Add all the connected load. 45.3 plus 36.3 plus 40.43 plus 50. You will get the total connected load for this SB panel. And for that, okay, 172.42. For this one again, calculate the maximum demand, that is 143.68, and current rating 1.4 into 143, the 201. Then 20% factor safety, that is 1.2 into 201. You get 241.39. So after two isolators, after 200, next available is 250. Okay, so that the isolator rating will be 250 ampere. Okay, so yeah, that's it. Our uh, that's it. Our SB panel calculation. Clear. So these things actually you have to do in CAD actually. This is just a schematic shown in for the calculation, but I have just taken this one. Actually, these things you have to represent in AutoCAD. I'll show it just a minute. Okay, so this is an actually a schematic for actually shopping mall in column. Here, so start from the SSB. So this is the SSBs given for ground floor, first floor, second, and third floor. Okay, this is SB and the common panel and the main HT panel. Okay, I'll come to this one in the next class. So for now, just don't bother about this. We'll start from here. Same thing. Whatever things we have shown in the PDFs, same thing is given here, but in the CAD formats. Actually, you have to create this CAD block depending upon the connections. Okay. So here, in this case, this is SSB1. Total consumed load is 53.28 kilowatt. Maximum demand is 44. And the location, depending upon the project or site condition, will change. Okay. Then here, it's given the it's a pilot light for the panel, and this is the isolator. Say TPN means triple pole neutral isolator is used here of 125 ampere. And this is the side from the DG as backup. Okay, so that one is shown here. Then below that, you can see it's a 125 triple pole neutral aluminum uh, cables we have used here. Okay, and for earthing, 25.4 by 3 strip earthing of copper is what used here. That's what mentioned here. Okay, and this is the bus bar. From the bus bar, we have taken 1, 2, 3, 4, 5, 6, 7, 8. So maximum 8 numbers are what taken from this one single panel. And this is the fuse. This is the energy meter, and this is the MCB of 32 ampere. Triple pole neutral is used, and this is the changeover. Changeover rating is used here. Okay, and below that is given the name DB bar GFRS one means okay, shopping mall. It's a shopping mall. So that distribution board, ground floor, first shop. Okay, and next one, this is the first floor, so it will be distribution board, first floor, shop one. So like that, depending upon the floor name change, you have to change the namings here as well. Okay. Okay. Now, for the first one, it is okay. Actually, here this is given in kV itself, so we don't have to convert to kVA once again. Only given in kVA, and here this is the kilowatt rating, and this is the kVA rating, and this is the current rating, 10.76, and based on the current rating, 32 ampere is the selected MCB rating, and the cable size will be 1 runs, 4 core, and 10 mm square. Length from the panel to the DB. What is the length of the cable? Okay, that is 145 meters given. Again, depending upon site, it will change. And earthing is done. Okay, so that much information you have to you have to provide in the downstream. Okay, similar for all the panels itself. Again, I think all are single phase loads. Okay, and coming to the second, sorry, first floor. Again, Okay, solar three phase again. Okay, so yeah, that's it. Our SSB panel. Now coming to the SB, this is SB panel. So yeah, this is the main incomer coming from the MSB. Okay, from the MSB, you have again one more isolator of a triple pole motor, 400 amperes isolator rating, and the total connected load for this one is 245 kilowatt. Maximum end will be 204 kVA. Same way, 400 ampere triple pole neutral aluminum bus bar is what used here, and for earthing 25 by 3 copper strip is used for earthing, and this is the symbol for the MCCB. Okay, for MCB it will be the symbol for MCB, and for MCCB there will be a box will be there. Okay, MCCB. Triple pole MCB is used here so that 160 by 125 is the rating here. Okay, and the connection is going to the ground floor SSB. So this is the SSB one. Okay, you can see that this is SSB one ground floor. That one is given here. Okay, and again second connection is also going to ground floor again. This is going to first floor. Again first floor SSB 2 3. That's what given here. And this is changeover from DG means this DC generator. Okay. So here you can see that only for the ground floor, this one is ground. Okay, I'll come to that in the changeover system class. Okay. Then FSB2, SB2 is given here, same way. It's MCCBs going to individual floors. Second, third floor is given here. Then one thing you can see that fourth floor, fifth, sixth are same. So the load of these three floors are same. So that's why only one panel is designed. So you don't have to duplicate this one. If you have the similar kind of load in the flows, we call it typical flows or typical load will say. So if it's typical, you don't have to copy this all the time. Just what one panel, then just mention that fourth floor, fifth floor, sixth are same or typical. Okay. Then again, something's already discussed. Beyond first floor, third floor, second floor. Okay, so each floor wise SSB and SBs are taken. Okay, so clear this one. Any doubts? How to design SB and SSB? Okay, so next steps is going to be motor panels and common panel. We'll come to that in next session. Okay, so motor panels. Okay, so tomorrow session we can discuss what the motor panels and the main ST panel. Okay.